My wife and I purchased this 20-year-old Class A motorhome and transformed it into our ultimate off-grid RV. Now in the last few years we've traveled all the way up through northern Canada, all around Alaska, back down throughout the western United States, and multiple trips down into the Baja Peninsula of Mexico, completely off-grid. So I want to tell you the entire story of how we got there with this off-grid setup, starting from conception all the way through completion of this project, and some things we also learned along the way. So buckle up, this is the whole story from start to finish. All right, well, there were several things on my mind before starting this project. You know, when we first picked out this motorhome, it had a lot going for it regarding solar. First of all, it was larger than our Class C motorhome. Our Class C was a 32-foot, and you know, this one is a 34-foot motorhome. But being a Class A, you know, it just seemed a lot bigger. There was a lot of room for solar panels on the roof. What's unique about this Winnebago Adventurer, it's a 2003 Winnebago Adventure, and it doesn't have any rooftop air conditioner units. There was plenty of room for solar. Sure, I had to remove the antennas and things like that that are in the way, but it really was kind of like a blank slate for solar panels, because I was kind of eyeballing some larger solar panels to be able to increase my energy density. I wanted to find some really large solar panels so that I could maximize the amount of energy that I could generate within the space available. These are used panels, and I think they came probably from a solar farm. This thing's about, I don't know, almost a foot taller than me. So this panel here still has a good sticker on the back which shows you the ratings. Probably about 3 years old, I'm guessing. So probably if it was coming from a solar farm, you know, they tend to recycle these a lot. So it still has, you know, probably a 20+ year lifespan, so we're good to go. These are actually SunPower branded panels. They have nice high efficiency Maxeon SunPower cells, which is what I am familiar with, and I really like how they perform. For a 435 watt panel like this, it was $175 each. I took some measurements on the roof and figured out where I could mount 4 of them easily, and that's going to give me 1700 watts of solar with 4 solar panels. So these panels are about 41 inches by 81 inches, and I've got enough room for 2 of these side by side here on the back. It still leaves me a little bit of room to squeeze by so I can get back and forth. I'll probably replace this Max Air vent cover since it's much larger than it has to be. It hangs out probably another foot past where it needs to be. Now I can get the other 2 mounted here towards the front, just right here, which is about right in the middle of the front and rear tires, so it's kind of right in the center mass of the RV here, and that still leaves me about 5 feet in front of them to access antennas and stuff. So nice having this spot. So I'll remove the satellite dish itself, but I'm going to leave the base of the satellite dish there, and I'm going to completely remove the TV antenna here because it's right in the way. There we go. All right. Hey, I can see inside. All right. For a mounting system, I'm going to be using this strut channel that you can get at your regular home improvement store, but it's galvanized metal. You can insert little anchors and all kinds of stuff that you can get for this, and it creates a nice supported little channel that you can move things around. You have a lot of flexibility on what you can mount here. I want to really distribute the weight of this panel along the roof and be able to support it the entire way instead of having individual pressure points on the roof. So this is going to allow me to do that. I'm going to need a lot of surface area to attach my heavy-duty VHB tape to the bottom of certain sections of it. So I think that's going to give me a lot of surface area, give me a lot of support, and provide me a lot of flexibility down the road for moving the panel back and forth. I can easily remove it, and I can either buy or make little brackets like this that will easily mount into the strut channel. Went ahead and painted these strut channels because I figured I'd regret it later if I didn't paint them white before I went ahead and mounted them to the roof here. So they're up here on the roof now. Paint's dry, and I also spent some time up here and marked out the placement of all these for the 4 panels. So the first step is actually to clean the surface of the roof here with some acetone. I want a really nice, super clean surface to mount to. I've already gone ahead and cleaned the track here, and I didn't paint the bottom purposely, and I cleaned the whole thing with acetone. So having 2 clean surfaces should give me a great bond. So what I'm going to do is mount them using this 1.5 inch heavy duty VHB tape, and I'm going to do that on each side, probably about 18 inches on the front edge, maybe a foot in the middle, and then another foot or 18 inches on the back. And that should give me plenty of coverage area so that it's nice and strong. And having those gaps in here are going to give it some room for moisture to feed out. Gonna also seal it up with some Sikaflex when everything's all mounted, and that'll help keep the moisture away from the VHB tape, and it'll just help it last longer.
Okay.
I just wanted to do one more thing just to make sure that there wasn't going to be any kind of lift or delaminating, because I know that the strut channel itself was secured really well to this outer fiberglass Phylon layer. But if you look underneath that, there's just one more like 1/16 of an inch of Luan under there. So it's just a little thin plywood piece. So that and another really thin fiberglass piece is all there is to this roof. And then you got like 3 inches or so of styrofoam. What I was concerned about was just any potential for that pulling away or maybe separating the fiberglass layer from the other layer. It was just a little added insurance for me. So just drilled a small hole, put a bunch of sealant in there, put in a bolt with a washer until everything came oozing out, and then covered the whole thing again with this self-leveling sealant. Now I also ended up replacing the brackets on the inside edge of these solar panels with a taller stainless steel bracket. Wanted to lift it up, so now the panel actually slopes a little bit from the inside down. Having it on the inside actually just gives me a little bit of a way for the warm air to come out and vent out, and also it gives me a little bit more space here for when I want to tilt the panel from this direction. And when I tilt it, this whole inside edge actually hinges up like that. So I replaced the washer in here with a vinyl washer that's going to just allow me to move this a little bit more, and I don't have to worry about, you know, having it too tight where it just won't move and I have to tighten it every single time. You can see the inside washer here, and then the outer washer, and then my 1/4-20 with a lock washer underneath it. Now when I do want to tilt the panels to maximize the angle to the sun, especially in the winter, I can do that on either side. So I can either raise both panels on the driver's side or both panels on the passenger side, and I do that from this outer edge in, depending upon how my RV is oriented to the sun. All I have to do is to remove this this bolt here, and it's a 7/16 1/4-20 little bolt, and insert this little riser. I think it's about 16-inch riser here. Just gets inserted right there. I can do this on both sides of the panel and just raise it up and secure everything down. It's got a little, you know, twisty here, so works really, really well. Kind of like this giant wing nut. Also a 1/4-20 insert here. I wanted to install some kind of baffle here on the front edge of the, especially on the front solar panels that are here facing the world as I drive down the highway. But I just wasn't sure, you know, what material to use for that, and I found the answer at the hardware store, and it was just a vinyl rain gutter like this. In fact, this is what's left of it. What I ended up doing is essentially just cutting it like this way, just using a cutting wheel, and then from there I could use it to cover that front edge of the solar panel. You know, on the inside mounting, I just took a simple L bracket and I drilled a hole through it, and I put in a rivet to hold it on, and then I could anchor the whole thing just using a nut onto the strut channel on one of those anchors, and it works really, really well. So now I've got all the solar cable run to this point here. And I've also got the cable running from inside the RV coming out the refrigerator vent here. And the next step is to get them all connected together. And I'm going to do that through this this box I put together. And it's got this little junction box inside where I can easily connect each cable in here and then decide how I want to join them together to connect to the cables going down into the RV. Now there's some advantages for doing it this way. First of all, I only need to run the cables from the solar panels once, and everything runs to this box here. And then from there on, if I want to make any changes to the system, I just redo some connections here in the box, and that's all I need to do. I don't need to run any new cable or anything like that. Another benefit is that I can use different cable from the solar panel to this box than I use from the box down into the RV. I mean, they're both 10 gauge cable, but this is rated for outside use. It's going to put up with a lot of UV stuff and sun and heat and temperature changes and just last for a long time outside, whereas this cable that I have running down into the RV is more rated for inside use. This is a lot easier to work with. You know, once everything's all set up in here, I can easily test things. So since all the solar panels are terminated in this box, if I wanted to test the voltage or current or anything on individual panels or sets of panels, I can just take those measurements right here on top of these connectors. And I don't have to pull apart any MC4 connectors or anything like that. Now, if you'd like to follow along with this install, I recommend you pause the video right now and go download the system diagram. It's at rvwithtito.com/download, and you can take a look at that while we go through this installation, and trust me, it's going to help. Let's go ahead and get this all wired up. Front right. Okay, so on this side here we've got our front two panels going into this set of four connectors here, and then coming at the other side we've got those cables just one-to-one heading down into the RV, and then the two rear panels are going into these four, and then on the other side we've got our internal wires heading down into the RV. So pretty basic, pretty easy. There are two spares right now, so if I ever wanted to wire up something else, I've got two additional bus connectors there. And like I said, the nice thing is when I want to test stuff, I can just put a meter on these little connections on the top, these screws, and then it'll give me voltage readings, and I can even do current readings across these connections when I want to troubleshoot or just test the panels. So pretty convenient to have everything right here. Now I was also able to get the internal cables wired up to the 4 circuit breakers that are going to control each of those charge controller inputs. And it was dark when I did this, so I just filmed part of it. Something that was real important to us was to retain the character of this motorhome. We kind of like the classic look of this rig. You know, I really wanted to come up with a design and a way to do all this solar stuff on the roof without changing the look of the RV. And I didn't want to spoil that with giant solar racking systems or anything on the roof that just screamed, "We've got solar panels." And the same was true on the interior. You know, we had a lot of new equipment that we needed to install, and you know, monitoring and all this stuff. And I chose to keep all of that hidden from view. Right here is actually where the converter charger was located. I removed it, didn't need it anymore, but it left this open area. And in fact, there's an open area all the way underneath this cabinet, all the way across. I decided to just utilize that space for the solar stuff. And this is where all of the solar charge controllers are located. And it's actually a nice compartment that's under this hidden floor space here. It turns out that this whole space is actually pretty well ventilated. What I've done is actually drilled some more holes through these little walls here for cable runs and for more ventilation that I can attach some vent fans if I need to. Right now I got the solar cable coming in. That runs to the solar charge controllers. I need to wire those up here. And then the output of the solar charge controller is actually going to go to this little guy here. It's a fuse block. Kind of similar to the link system, I suppose. I mean, it's just a really inexpensive version, but it kind of accomplishes a similar function without all the automation. All the outputs of the solar charge controller will go here, and then out these very thick 1/0 cables. You know, there's potentially a couple hundred amps that could be running from the solar, so I needed to make sure that I accounted for that with the cabling. Finally, there's just a whole bunch of this Victron communication gear. All of these charge controllers have to be connected to the Cerbo GX, so I have these VE Connect and VE USB converter cables to make sure that I have a place to connect all of those. We'll get everything hooked up, and then we'll circle back and I'll show you what it looks like when it's done. All right, now a question that I get a lot is, why did you go with 4 separate solar charge controllers, like 1 per panel? Wouldn't it be better to just have 1 large solar charge controller, or maybe 2, you know, and separate the solar panels into 2 separate arrays? Now, yeah, those are all viable options, but I chose to go with the 4 solar charge controller direction because it really is the most efficient way to get energy. Each panel now is completely independent from one another. So, you know, as we move in areas where we get a little bit of shading, or where the sun rises and sets and only hits a portion of the panels, and we're constantly on the move, you know, there's going to be a different amount of energy hitting each panel. So having each panel working on its own independently, and then have everything parallel together before it goes into the batteries, is really the most efficient way to do it. And I've proven this a number of different times, you know, while we've been in different environments and, you know, different positions where we're hitting the sun in different ways. So that's why. Another thing is that these panels are very large, and they output about 75 to 80 volts. So If I were to combine them in series or parallel, I'm either upping my amps or I'm really upping my my volts. And to be able to get a solar charge controller that is rated for those high voltages or high currents, it's still going to be a lot of money, and they're going to be very expensive. So, you know, this is really the best route, and you know, in the last few years, it's really proven to be the most efficient way to do it for me. With this being a 50 amp RV, you know, we needed to find an inverter that could handle the 50 amp pass-through service from shore power, as well as accommodate, you know, powering the whole rig from a single phase or lower power source, you know, with just using a single inverter. So that was a challenge that that we decided to handle by going with, at the time, the newer Multiplus 2 dual channel, the 2 times 120 volt AC inverter. Now I've already gone ahead and connected everything ahead of time, because there's a fair amount of setup using the Bluetooth and connecting it to the app and being able to configure the charger settings. So I'll show you all of that later, but I've already got it tested here in the shop so that I don't have to do all that stuff out in the RV. So what I wanted to do is actually show you, do a quick little scribble here. So I'll draw a little diagram, and maybe that'll help you understand what I'm doing. Now this may not be exactly the same as your RV, and this is going to be, you know, how our RV is set up. So coming in to the RV, whether we have our shore power connection or our generator connection, now these are AC inputs, they're going to go into our transfer switch. So this is our transfer switch here, and we've got our shore input coming in that way, generator coming in that way. So either one of these is going to have power on it going into the transfer switch, and we're going to have a single output from the transfer switch. So the way the transfer switch is going to work, it's typically going to be on the generator priority, which means that even if there is power coming in on the shore power connection, if the generator fires up and then there's an AC power coming in here, the transfer switch is going to switch to the generator, and then when the generator shuts off, it's going to switch it to the shore power connection. But in either scenario, we're going to have one output going to our AC input panel. So this is our AC distribution panel, where all of the circuits in our RV are going to be powered from, and that's how the system works. This is actually located towards the rear of our RV, and this is kind of by the entryway, very close to where I'm installing the inverter. So for the Multiplus to actually live in here, I'm going to install it kind of right here in the middle. So if we take part of this out here, you can kind of see that the inverter will actually go in right there. So this will be going into our AC in, and this will be our AC out this way. Okay, so basically I'm going to remove the AC coming in from the main distribution, and I'm going to reroute that to this input, and then the output I'm going to run some new cable, which I got here. So I've got enough length of this cable. This is a 6x3 with ground, so we have 6 gauge, 3 cables that are 6 gauge copper, and it has an extra ground. So that's what it's called if you want to go get some. So 6x3 with ground. And this is very similar to the existing cabling that's in the RV. So I'm going to run that from the output to the AC input. If we're in a situation where I'm either connected to shore power or generator, there's going to be an AC signal coming in here to the inverter. So in that mode, it's going to just basically pass that through to the output, And it's also going to charge our battery bank. So let's just say we have our 810 amp hour batteries here, and we've got our positive and negative DC inputs. While we have shore power or generator, it's also going to charge our batteries. Now, once this kicks out, so there's no power here, no AC power coming in, then the inverter is going to be it's going to switch to inverter mode, and it's going to take power from our batteries here and then create AC power output. So that's kind of how it's going to work. It's either going to be in this pass-through mode, or it's going to be in inverter mode. If we look at the back of the inverter here, where we can make all of our connections, you can see we have an AC in and an AC out. And they both have 4 connections there. We have a neutral, we have our L1 and L2, which are 2 of our hot lines and a split phase setup. And we've got our PE, which is our ground, our earth ground. And they're both identical. So in a really basic setup, which is how I'm going to have it set up, is that we have our input going into the AC in from our shore power or generator or transfer switch, if you have that. And our main output to our power panel in our 50 amp service is just going to come out here. And that's pretty much it. And we'll also have our battery negative and positive terminals coming in here and connecting to these terminals here. So that's the really basic setup. Now in this inverter we also have a secondary AC output, and that's just an option if you wanted to specify a sub panel or something that has specific circuits on there that are critical, and you wanted to separate those from this other output. You can control when that is powered or not inside the settings of the inverter. The inverter also has a lot of other inputs and outputs here, depending upon how you want to configure it for different types of applications. You can turn on and off certain relays and set it up for different types of sensors and things that you can plug in here. The main ones that I'm going to be using are these 2 communication ports here that are the VE bus connections, and those are like RJ45, like standard network type of plug connectors that I'm going to use to connect the Bluetooth interface and to connect it directly to this Cerbo GX module that I'm going to also install, and that's kind of a communication hub module that will allow me to have this color display, touch display, and connect it to Wi-Fi and the internet and all that stuff to do a bunch of fancy monitoring. I wanted to give you just a quick rundown of what I plan to do. Now I've already removed the cover for the AC distribution panel here, and you can see where the main cable comes in, main power cable comes in down here. We've got our 2 hot lines, and we've got our ground and our neutral, and you can see how everything's wired up. So essentially what I'm going to do is I'm going to remove all of that and pull it all back to the point where I can bring it into the compartment below. So one more thing, before you disassemble anything, any DIY project, it's always a good idea to take a picture of it first. And you'd be surprised how often that comes in handy. Got it all run and got my new cable here. Pretty much just going to wire it up the way that it was wired up before. I got my neutral, that's going to go in through here, ground to here, and I got my 2 hot lines here that are going to go right there. Alright, got the main cabling done. Now I gotta just mount and hook up the inverter. So yeah, just a lot of connections that we already kind of went over, so I'm gonna go ahead and make those connections, and I gotta drill some mounting holes and things like that, and hopefully we'll get this sucker fired right up. Alright, well, I got my power back. The inverter is mounted nice and solid here, and it's in pass-through mode right now. So I got my 50 amp electrical service reconnected back to the RV, and you can see here is my incoming line from my transfer switch, and I went with a blue wrap on the output from the Victron, so I can tell the difference between the two. But yeah, everything's working, and I already have a few cables connected to the inverter here so that it's ready to go when I get the batteries in. But one thing I did do is, you know, I broke out my laptop here and hooked up this this USB VE bus adapter, and I needed to do that because I needed to disable the battery charging, because when I fired it up, it automatically wanted to kick into a bulk or absorption charge for the batteries, but obviously I don't have any batteries yet, and I don't want these battery cable outputs energized. So yeah, turn that off. I basically did that through my computer here and the Victron Connect PC application. I had a pretty good idea of what kind of capacity I wanted in terms of lithium batteries and solar. In our previous RV, we had 400 amp hours of lithium batteries and about 900 watts of solar that we could get up there on the roof. Now, we got pretty comfortable having that much, and we kind of knew really how we would use that throughout the day. So I figured with this rig, my goal was to double that. And I figured if we could double that amount to around 800 amp hours of lithium batteries, and let's say, you know, 1500 to 2000 watts of solar here, and a nicer inverter, then we would be really in good shape. You know, we could do anything, we could power the entire house. So that was my goal, 1500 to 2000 watts of solar and about 800 amp hours of lithium batteries. Double the solar from the battery capacity. So there's 3 of these batteries, and I guess they're just heavy enough, they have to lay them on their side, and they had to come on a pallet. But it didn't cost me any shipping, so that was no big deal. Eventually I got around to doing a top balance on them. Now this isn't something that you normally have to do if you're connecting them in parallel, you know, according to Battleborn. And I am connecting them in parallel, so 3 of them in parallel to get that 810 amp hours of capacity. But I have a bench power supply here that works good for that, and I can just set it to 14.6 volts and a low amperage of about 2 to 5 amps, and just slowly top each battery off one by one. Now, once it hits that 14.6 cutoff, then the amperage starts to really drop down. That's how you know it's full. I went through that process for each of the 3 batteries individually and just let them sit for a couple days, and then started working on a way to connect them all together in parallel. Now, because of the really nice battery posts that they're not even posts, the battery terminals that they have on these batteries, I was able to go for more of a bus bar setup on these and not have to use any battery cables or make any battery cables to connect the batteries. I ordered some copper stock from eBay, and when I got them, you know, I cut them down and started making these custom sized bus bars to connect them. After they were all connected in parallel with these bus bars, then I just let them sit and they just balance each other out and eventually settle down to, you know, lower voltage until you put a load on it. They also fit together very nicely, and they have some holes in here that you could, I guess, bolt them down or whatever. But I also found that quarter 20 bolt actually can be threaded in this thick, must be like really heavy-duty ABS plastic. And I was able to kind of tap some threads inside these just very slowly so it doesn't get too hot. And I was able to kind of thread these out and then make these some custom brackets that fit over the holes. And that seemed to make this whole setup really secure. Now it turns out that these little mounting feet on the batteries fit very nicely in some strut channel. So I had some leftover strut channel from when I did the solar panels, and it just snugged them right in there, and that's how I'm gonna mount them inside the compartment. Now, as cool as this setup is, at least I think so, it's all going to be hidden anyway. So I made a front piece of wood that's going to be covered with this carpet material, and it's going to hide all of this stuff from view if you were to look inside at that compartment. Now I only had to make 2 battery cables. And didn't have to use any cables at all to connect the batteries to each other and to the shunt and the bus bar. Now these 2 cables are 4-aught cables, and they're going to be used to power the inverter. It's going to stand up here. I don't really enjoy making battery cables. Could you imagine how many cables I'd have to make if I had 8 individual batteries to get to that 800 amp hours? I only had to make these 2 cables, which worked out really, really nice. I'm going to remove the 2 house batteries. I've already flipped the main battery disconnect here off, so there's nothing connected to the batteries. Take it out. We got no house batteries now. And there's the old guys. I'm jumping forward just a little bit. I got a couple other things done that I want to show you. First of all, good news, the inverter and the batteries are all connected, hooked up, working just fine. I also disconnected the existing converter charger, so it's not providing 12 volt DC power right now. Don't need it anymore, but I'm gonna leave it for now. I'll actually physically remove it soon. I just haven't gotten around to it. One thing I wanted to show you was actually how I connected the battery to the existing 12 volt system in the RV. When I removed the batteries from the battery compartment that's right next to here, you know, I still had those positive and negative cable that connected them to the coach. So what I ended up doing was actually just running 2 additional cables, red and a black, from the bus bars here on the battery, and then just running them through this hole in this conduit to that compartment on the other side. And I had an extra bus bar, and then that's how I joined that to those existing cables that are already connected to the coach and all the relays. And once I did that, everything just, you know, fired right up, and I had 12 volt power. Having that bus bar available there now really makes it a lot easier for me to add additional 12 volt circuits throughout, you know, the underside of the rig. Like I plan on, you know, hooking up a 12 volt power to an air compressor, and so it's just a convenient place to be able to make those connections now. All right, the other thing I wanted to show you was the way I secured this whole battery bank to the coach from the top and the back. Now, I didn't want it all resting on the bottom of the compartment here because it's just a lot of weight, and I didn't want to have to support it from the bottom, which I've done in the past for our Class C. But what I did is I got some 1/2 inch threaded rod, and since I do have this strut channel that it's sitting in on the bottom, I could put an anchor bolt in there, and then on the front side, and this is going to be the same on both sides, so I'll just show you this side, it's easier to access. Now in the front, so I have this this rod that goes all the way up, got a little sleeve that connects 2 rods, and then it actually goes through the top here, which goes through the floor of the RV. And I have a metal plate that's going through, and a bolt at the top, so that allows me to actually pull this up to the top vertically, just enough to take the weight off of this compartment. And then the back actually has another big metal plate, and it's bolted into this other piece of strut channel at the bottom, and then bolted to the back shelf there that has a lot of support. So between the 2 of these on both sides, I'm actually able to tighten down those bolts and actually lift the entire battery bank up just enough to take that weight off of the compartment. And then finally, to keep it from shifting around in transit, I put a couple of lag bolts here, and that's enough to just keep this whole thing from moving at all while the RV is in motion. Now everything that's part of this whole Victron set of components is wired and connected to the Cerbo GX, which has a touchscreen display, a control unit inside. I'll show you that in a sec. The Cerbo GX is actually connected via Wi-Fi to the internet, so I can manage and monitor the entire system remotely through the Victron mobile app. And I'll give you a snapshot of that. Super nice to have. But there are lots of different interface ports up here. The ones that I'm using are the VE Connect interfaces, and I see that I'm using 3 of these. There's like 3 of these here, and this is an HDMI port at the top which connects to the display unit, and there's looks like a kind of a network connection here. It's like an RJ45, like a, you know, Ethernet type of connector there that connects to the Multiplus 2 inverter. So the inverter is actually connected through here. All the power coming in and out of the batteries is actually connected to a Victron Smart Shunt located right behind here, and the shunt itself is connected also to the Cerbo GX. So I can monitor all of the power consumption and measure the battery's state of charge through the smart shunt. Now, something I learned about the all these different inputs to the Cerbo is that you may find that you'll run out of places to plug stuff in, because it has a limited number of USB connections, a limited number of VE Connect inputs. If you run out of inputs, physical inputs here on the device itself, different connections, what you can do is actually get just an inexpensive USB hub like this one I picked up on Amazon. Nothing fancy, just 10 bucks or so. You can just plug in this little hub to the Cerbo, and this is just a 4-port hub, and that allows you to just connect more USB devices using the USB or VE Connect to USB adapter, and you can plug in more USB stuff. As long as you don't exceed that, I think it's 16 total inputs to the Cerbo. Now you can manage just about everything that you need to through this touch screen interface that's connected to the Cerbo GX. Now, having the ability to remotely connect our system to the cloud, I guess you could say, through Victron's VRM system, I think it's Victron Remote Management System, is huge. I mean, we can look at our setup and make changes. Here's the VRM screen on the app. We can access this information anywhere in the world, and it basically gives us full access to be able to do things, to monitor the state of our batteries and whatever devices that we have connected here. So it's got a real-time widget that shows the state of charge of the batteries and other things on our system here. So another really handy thing. It's free. All you need to do is set up a VRM account and create a login, and then you just connect the app to your account, and then you can see all your stuff. And there's a web version also, so if you open your browser, go to the VRM site, you can see all of your information, as well as a ton of historical data. It's really cool to just see all of that information over time, and see what your maximum PV inputs have been. The Cerbo GX and the other GX module provides a lot of this communication and connectivity that's it's just a real step above everything else. What equipment, and appliances and all this stuff can we actually run on our system? And the answer is we can run and power everything that we need to. And it's more an issue of managing that power and figuring out how long we want to actually run those high draw things so that we don't pull our battery bank down lower than it needs to be. And we can run the microwave, no problem. We have a Keurig. We have an air fryer, so we fry stuff. We have an induction plate. So we try to use as much AC power as we can during those peak hours when we're getting lots of sun, and everything else pretty much just functions like a regular home. Now, the system diagram, as well as a full parts list and equipment descriptions and a whole write-up, all of that stuff's available for download at rvwithtito.com/downloads. And if you want more detail about any part of this project, there are detailed videos available for all of the different phases of this project in the playlist that I'll also link to. So you can go ahead and binge watch all these if you want to, if you haven't already seen them already. But I look forward to hearing from you, and I will see you in the next one. Take it easy.